So the idea is to determine whether you got it right or wrong. And if you got it wrong, write down the correct answers. Try to learn from your mistakes. But before we start, I wanted to tell you that I'm pretty impressed. I walked around and I saw a lot more positive results. Not necessarily right or wrong answers, but process. You guys really starting to understand how to solve a complex situation like this. And really all I did was take the question from last time and I took away some of the picture. I gave you kind of a basic picture. I was very impressed. Some of you took the picture and drew the information in. That was excellent. So let's see what the right answers are, and then we'll work from there. I'm going to reveal my equation. You know what? Let's actually start with part B. Let's start with part B and just get the answer. So how wide should each picture be? We've got 1, 2, 3, 4, 5 confident people. We'll start here, there, and there. Go.
1.5 inch.
Okay.
1.5 inch.
2. I'm sorry, I'm missing somebody. Brian? I apologize. Brandon, go ahead. So we have a number of people, 1.5. Someone thinks 2. 1.5. The correct answer is 1.5 inches. Now, what equation could you have used to do this? There's quite a few different ones, but it all comes from the same basic information. So here is one form of the equation. So let's go over the pieces. First of all, could someone tell us what that is? What's that? You guys got it? Very good. Now put it in the context of solving a problem. What have I told you that that is? Tristan? Say it a little louder. The total. That's the first thing you try to find is the total. In this case, we were talking about the width of the page is 8.5. Very good. So now let's go piece by piece. What was this? Sebastian?
The margin.
Very good. So it says the left margin is 1 inch, so we're talking about this distance right here. That's the 1. What's the 2.5? What's the 2.5, Alyssa?
The right margin.
The right margin, and in this case, and this is pretty realistic for like a magazine or something, that they often have text or something, or maybe even some small pictures on the right. So that's that distance, that's the 2.5. What is this? That's a complicated looking expression. What is that? Anne? Very good. So it says the space between each picture is 1/4. I understand that. Where did I get the 2 from, Anne? Okay. You can say it really simply. What's the 2 mean?
Oh, it's like 2 times 1/4.
Right, but why is it 2?
Because
There's 2 spaces, exactly. And so that's this space and this space. So we're trying to figure out the missing piece. And so, what does that represent? Kayla?
The picture.
Okay, very good. Why is there a 3 there? Exactly. And so that was the part that you had to interpret, was that that's an X, and that's an X, and altogether that's 3X. So you could have written an equation that looked like mine. You could have, instead of doing this, you could have put 1/4 plus 1/4. I saw some people did that mentally and did 1/4 plus 1/4 is 1/2. So I don't want you to mark this wrong if you don't have this exact equation. If you have all of these pieces somehow represented and you got the right answer, then you've got an equation that works. Does anyone have any questions or comments? Catalina?
I feel like I did my equation right, but I didn't get the answer.
Okay, so what was your equation?
In parentheses, I put 8 and 1/2 minus 2 and 1/2, and then I minus 1 equals 1/2 plus 3x.
So is there an equal sign in there?
Yeah.
There was. Let me write it down one more time. Let me write it down. Say it one more time. You wrote in parentheses 8.5
Yeah, minus 2.5.
minus 2.5. So you're subtracting the right margin. Okay.
Yeah, and then minus 1.
Minus
1
1.
equals 1/2 plus 3x.
You subtract the 2.5. You subtract the 1. Seems like it should work. After I get everyone going on the grading their homework, I want to do it on a separate piece of paper myself and see if it works. Because you might have just made a computation mistake somewhere.
It works.
It works? Oh, okay. Good. I mean, I think it should work. So we just have to check your process from there. Okay? Maybe you added a couple numbers wrong or you subtracted wrong. Okay? Thank you, guys. That's excellent. Okay? So again, I'm glad she volunteered because look, this looks pretty different than this. And in her mind, this makes sense. For some of us, it may not, but that doesn't matter. It's what makes sense to her that's the most important. Okay? Good. Any other comments or questions? Good. We're doing quite well. Put this warm up to the side, please. Today, we're going to be continuing our study of graphing. When I gave you the overview of chapter 4, last time we were together, I outlined the fact that you were going to learn 3 different methods for graphing a linear equation. So last time we explored scatter plots, and that was graphing, but today we are going to more formally define the process of graphing a linear equation. So today is the first method. Okay? First of all, when we talk about graphing an equation, we have to talk about solutions of an equation. Up until today, you're used to a solution looking like x equals 3 or z equals -9. That's what a solution has looked like up until today. But now we have 2 variables. We're talking about equations. They're still linear, but they have 2 variables, x and y. So a solution looks different. A solution is now an ordered pair. That's what a solution to an equation is. It's an ordered pair that makes the equation true. A graph is really all the solutions. That's what a graph is. You were also used to, up until today, when you solve an equation, there's one solution. Or sometimes there was no solution. And every once in a while there was infinite solutions. We learned those special cases. But we were used to really looking for one solution. Well, today and from now on, we're not really working like that. Now we're looking for many solutions. But it's not infinite. They're very specific. And when you find all the solutions to an equation and you plot them on a coordinate grid, they form a graph. So when we talk about a graph, we're talking about all the ordered pairs that make the equation true. Now, some of you are bright enough that you will instinctively know how to do this. But I don't rely on instincts. From now on, anytime I'm teaching a new process, I will outline the process for you as a sequence of steps. So, today, I've outlined the process of graphing as this sequence of steps. So, the method we're learning is called graphing using a table of values. So, this is what you're going to be learning how to do today. You actually already know how to make the table of values. You actually learned last time how to plot the points. We just have to put it all together. Step 1 is we're going to rewrite the equation in function form. Well, what's function form? Just a couple of light bulbs of recognition. Oh, we got like 7. Come away.
An equation that can be solved.
Okay, an equation that can be solved, sort of. I think I see where you're going with that. Sebastian?
Ax plus by equals c.
Y equals,
Ax plus by equals c.
ax plus by equals c. Well, that's actually not function form. That's actually a different form that you actually were asked to memorize. Sharif?
Same thing as slope-intercept form, y equals mx plus b.
Pretty much. You learned function form at the end of chapter 3. And at the time, I talked to you a lot about how this was a critical leap. Well, this is why. Because now you're going to be using it every day. So rewriting an equation in function form. Some of you, you're going to get tripped up a little bit, but I'm not going to slow down. You were already supposed to be an expert at putting something in function form. If you're not, you're going to have to come up to my level of expectations. Don't worry, we'll get to that in a couple of minutes. Step 2. Choose 4 values for x and make a table of values. And then finally, plot the points and make a line through them. So if you think about it, you already know each of these individual steps. You learned how to do step 1 in chapter 3. You learned how to do step 2 in chapter 1, and we reviewed it again last time. And step 3 you learned in chapter 1, and we reviewed last time, except for the part about drawing a line through the graph. So today we're going to jump right in and do one. Since the process takes a while, we're going to do just a few examples. So you have to extract your understanding of the concept from just a few examples. That can be hard. If you're struggling, if things aren't making sense, you got to ask questions. If that's uncomfortable for you, then you have to see me during STAR or during CARE. Okay? So, example 1. We're going to graph this equation using a table of values. The equation we're going to graph is x plus 4y equals 4. I have set up my workspace with 3 different areas. I did that on purpose so that it would be easy for you to follow along. You should do that for the first 1 or 2 that we do. You don't have to draw boxes. I have a computer that does that for me. But you should have step 1 labeled. There should be space for step 2 and then step 3. Could someone refresh us? What's step 1? Step 1. Caleb? Rewrite the equation in function form. So the equation is x plus 4y equals 4. I want it in function form, which means when I'm done, it should be y equals something. So, someone start us off. What's the first thing we're going to do? Darby? Jada?
Minus the x.
Sorry about that. So, subtract x from both sides. Sorry about that. Subtract x from both sides. Because remember, when you're trying to get y by itself, you should be looking at the side with the y. This will disappear, and we're left with the 4y equals, and now we want the x term to be first, so we'll write negative x, and we still have this 4 plus 4. What's the next step in putting it in function form? Anita? Very good. But what I taught you was to divide everything by 4. So I actually taught you to do this. Divide by 4, divide by 4, and divide by 4. Today is y. So we divide by 4 here, here, and here. This cancels out, and now we have to simplify everything. So how can I write this in a really effective way? What does that really become? Zabari?
Y equals negative 1/4 x.
Just stop there, stop there. Negative 1/4 x. That's really what that means. What about the last part? This part right here. What does that become? Oh, got a lot of people. Tristan? Plus 1. So we have it in function form now. Y equals negative 1/4 x plus 1. Comments or questions on how we got to the function form? Kamoy?
For the part where you divide everything, I mean not everything, you subtract x. If you wrote 4y equals 4 minus x,
It's not wrong, but you're going to find when we get to slope-intercept form that you're now struggling. I'm trying to lead you to slope-intercept form a week from now. And so I'm trying to get you in good habits now. The good habit now is to put the x term first. So I'm not saying it's wrong, but I'm saying we want the good habits. Okay? Does that answer your question? Good. Any other comments or questions? Good. So now we have the result of step 1, and the result of step 1 leads us to step 2. Step 2 is to do what? What's step 2? Anissa?
Choose 4 values for x and x.
Good. Make a table of values. So you should be an expert at this. We're going to make a table. It's going to have a small column on the left, a small column on the right, and a wide column in the middle. This is x. This is our function. That's not right. And this is our y, our output. Now, I did not give you a domain. Last time I gave you a domain, it was like -4, -2, 0, 2, and 4, something like that. I'm not giving that to you now. Now I'm saying you have to choose the numbers. Now normally I would choose 4 simple numbers. Usually you want to choose at least one negative because you want to see what happens when it's negative. So I would do something like -1, 0, 1, and 2. Don't write this down, but this is a normal selection. -1, 0, 1, and 2. And notice I listed them from smallest to greatest. Now we can do that, but I want you to look right here. If I plug a -1 in there, simplify it, and then add it to 1, am I going to end up with a friendly number?
No.
No, it's going to be pretty unfriendly. And I have to then graph it on a coordinate grid. And that's a pain. And since accuracy is really important, and we want to use these lattice points to help us, we can actually do a better job. If we spend about 5 seconds thinking about it, we could actually make a better selection of numbers that will make the outputs come out really nice. So I want you to take a moment to think about this expression and what numbers we could choose and come up with I'm going to call on volunteers. What number could we choose to plug in that would make this come out really nice? So we got 1, 2, 3, 4, 5, 6 people already. Sebastian, we'll start with you. -4. Alyssa, what were you going to say?
I was gonna say -4, but
Okay, no, stay with that. So -4 is a fantastic choice. That's what I would choose as well. Now, I've been doing this for a long time, so my instincts immediately kick in. The reason we want to use a -4 is because when I plug a -4 in right here, this becomes a
Positive.
It becomes a 1. So it becomes a very friendly number. So what would be my next number, Alyssa?
0.
Yeah, I would do a 0. 0 makes things really easy, so I would do a 0 as often as I could. What would I do next, Ania?
24.
I'm sorry?
24.
24?
Yeah.
Well, we could, but if I plug in a 24, I'm going to end up with a larger number. There's probably a better choice. There's nothing wrong with doing 24, but you're going to see in a minute what would make a little more sense. Eric?
4.
4. And then what would be the next logical one? Alicia? 8. And so if you just notice that the denominator here is 4, that can guide you on what numbers to choose to make your life easier. This is something I expect you to be able to do. So now let's go ahead and plug in everything and find the output values. -1/4 times -4 plus 1. What do we get? Aliana?
11.
We do not, unfortunately, get 11. You don't need a calculator for this. That's why we chose those numbers. Maria?
0.
You do not, unfortunately, get 0. I'm sorry. We're missing basic detail. Eric?
2.
You get 2. You get an output of 2. Ladies and gentlemen, what happens when you multiply a number times its reciprocal? Brandon? Becomes a 1. This is a number times its reciprocal. You get 1 plus 1 is 2. Okay? So now, 0 as our input. -1/4 times 0 plus 1. That's super easy. What will we get as the output value for that? Kamoy? 1. Next, we plug in the 4. -1/4 times 4 plus 1. What will we get as our output value there? Aliana?
0.
Now we will get a 0. Anyone see a pattern going on?
Yes.
Anyone see a pattern?
Yes.
So, what if you can make a prediction, what do you think the next value will be? Hezekiah? -1. Let's see if he's right. We'll plug in the 8. -1/4 times 8 plus 1. That's a -2. That's a 1. It does come out to -1. So you can use the concept of patterns to help you find shortcuts. Patterns will emerge if you have the same distance between all your input values. You should end up with the same distance between all your output values. Now, if you had followed Ania's advice and put in a 24, you would still get an appropriate value, but it wouldn't fall within the pattern. It would fall outside the pattern. There's nothing wrong with that, but I think we could have actually figured out what the values would have become without doing any of this work. Does anyone have any questions so far? Good. So now we put the x's and the y's together, and this is now an ordered pair. This is a solution to this equation. If I plug these numbers in for x and y here or for x and y here, I will get a true statement. So now I have ordered pairs that are all solutions. So now we need a coordinate grid, step 3. We're going to plot the points, and we're going to draw a line through them. Don't make the hugest coordinate grid on the planet. Don't make a tiny coordinate grid. You need about, I'd say about 8 squares in each direction. And then we're going to plot the points. So the points were -4, -1, 2, 3, 4, 2. So our first point is right here. Then we have 0, 1, 4, 0, and 8, -1. Since we are talking about linear equations, you should see the points in a line. If you don't, that means you made a mistake somewhere, most likely. Now we're going to connect the dots. And the reason we connect the dots now is because we can assume that everything in between is a solution, because we were not given a specific domain. So, we want the line to be accurate. I did not do a very good job. You can use a ruler or a straight edge. You can use the edge of your binder. And you want it to go all the way across your grid. There is an arrow on either end of the line, and that represents that the line goes on forever and ever. You must have your line go through the entire grid and through both axes, the X and Y axis. I've seen this in the past where students plot a few points and they give me a graph that looks like this. They go, okay, I got it, Mr. Gallagher, here's my graph. That's not okay. That's a lack of effort and understanding. The graph needs to go through the entire grid. Okay? Does anyone have any questions on how we got this graph using this information? Questions, comments, concerns? No questions? Okay, let's see how you do on your own. Checkpoint number 1. A little bit of a longer process. So you've got 4 minutes, 4.5 minutes to graph the equation. I gave you a little bit of a tricky one. Make sure you pay attention to details. If you get confused, raise your hand and I will help you. All right. Colored pens. It is difficult to get volunteers for a question like this, so I'm going to reveal the graph, and I'm going to reveal the table that I used. The graph, you could get a whole bunch of different ways. So as long as you have the correct graph, it doesn't really matter what table you used. Here's what your graph should have looked like. You can see the points pretty clearly. Here was the table of values that I used to get this graph. So I saw as I walked up, I got a chance to walk up that section over there, and I saw a lot of people with the exact same table. So even though the function was a little bit harder to get into function form, well, actually it really wasn't, but it's actually easier than the one we did together. And since there's no fractions anywhere in this, you don't end up with any fractions, you should use the simplest selection of x values. The simplest selection is -1, 0, 1, and 2. Now, if you did 0, 1, 2, 3, that's fine. You should still end up with the same graph. But it is pretty important to see what happens when you make x negative. You want to get this point right there, because you want to see what happens when it goes across the x-axis. So are there any questions or comments on this? We'll start with Kamoy, Ania, and then Brandon.
I used the same numbers as you for the domain, but I got 3, -2, -7,
Okay, so let's check and make sure you have the correct function. So could someone tell us what does this become in function form? Jada?
Because y equals 5x plus 2.
Y equals 5x plus 2. Is that what you had?
I put -5.
Okay. See, what happened is that I think you took the -5x and you subtracted it from both sides. Okay. But then you end up with everything on the right-hand side. What's the goal of function form? You are trying to get what? That's right. So which side of the equation should you have looked at? Yeah, the right side is the side with the y. So even though you didn't do anything horrible, you ended up getting yourself into trouble. You should have been looking at this side only. And what do we need to do to get the y by itself? Add 2 to both sides. And then use the symmetric property of equality. Do I still have it up here? No, I don't. The symmetric property of equality says that if you have an equation that looks like this, you can flip the whole thing around and make it look like that. It's up there as well. Symmetric property of equality says once you have an equation set up the way you want, you can flip the whole thing around the other way. So just because the y ends up on the right-hand side is fine. Then flip the whole thing around and you end up with this. Okay? Ania and then Brandon.
How do you know
Well, what's the major difference between this one and the previous example? Look at this number right here. That number is going to get multiplied by our x values that we choose. That's a whole number. So multiplying it by a whole number is easy. But in the previous example, this was a fraction. If I multiply that by a 1 or a 2 or a 3, I get a very ugly number. -1/4 times 3 is -3/4, plus 1 is 1/4. Is 1/4 easy to graph on a grid like this? No. So we want to try and avoid ending up with output values that are fractions, because they're hard to graph. In this case, we won't end up with fractions no matter what. So pick the simplest values you can to plug in. Okay? Brandon?
Do you mean like the same graph? Do you mean like the same slope of the line?
I'm sorry?
Like the direction? I mean like the slope of the line.
What about it? I didn't hear the beginning of what you said.
When you say the same graph,
Yes. When I say the same graph, I'm saying that you should get this exact same line no matter what values you pick. Because you might end up with a point up here, or way down here. But when we connect the dots, it should still be the exact same line. Okay? Does that answer your question? Good. We seem to be doing pretty well. Are there any other comments or questions? All right, so now, that's one major goal for the day. One major goal is to be able to graph. Another goal is actually a little bit easier, but I have to make sure we understand. Decide whether each ordered pair lies on the graph of 2x plus 3y equals 6. I do not know why this is here. So, this is a fancy way of saying determine whether or not this is a solution of that. Because if this is on the line, that means it's a solution. That's what the line represents. Let me go back here for a second. Every point on this line is a solution to this equation. No matter what point I pick, anywhere on this line, if I pick that point, if I pick the coordinates and I plug it in, it will be a true statement. So that's what this whole thing is about, is representing all of the solutions. So now what I'm saying is, I think this is a solution. You prove to me whether it is or not. So it's a simple process. Anyone know the process already? We got 2 quick hands up. Catalina?
You plug in the 3 to the x and the -4 to the y.
That's it. You plug in the numbers and see if you get a true statement. If you get a true statement, then it's a solution. If you don't, then it's not a solution. And that's it. And her explanation was spot on. 2 times 3 plus 3 times -4, does that equal -6? Most of you could do mental math to figure that out. That's a 6, that's a -12. So is it a solution or not? Give me a thumbs up if you think that's a solution. Good, you should put your thumb up. So this is a solution, so the answer is yes. When I graph this, this will be on the line. It is a solution. Does anyone have any questions on how we did that? So let's check -4, 1. Plug it in. 2 times -4 plus 3 times 1. Does that equal -6? Give me a thumbs up if you think it's a true statement. Good, you shouldn't put your thumb up because the answer is no. What that means is this is not a solution and it is not on the graph of this. So what does that look like? Well, I don't have time to do the graph, but if we look at this one, all of these points are solutions to this equation. If I pick a point not on the line, what if I pick this point right here? That's -5, 10. -5, 10. If I plug this into here, will it be a true statement?
No.
No. So only the points on the line will be true statements. Okay? Any questions about that? Good. We seem to be getting it. So now we're going to take it to one extra... Oh, no, I'm sorry. I have a checkpoint. A quick one. Let's see how we do on our own. My apologies. This is a bit quicker than the last one, so let's go with a minute and a half or so. And I'm looking for a yes or no answer, but you need to be able to prove it. Remember, you don't have to copy down checkpoints, just whatever work you need to do to get it right. Next, we're going to do this by survey. Give me a thumbs up if 3, negative 4 is a solution to that equation. Thumbs up. Got 1, 2. 2 people think it is a solution.
No.
It is not a solution to the equation. What about part B? Give me a thumbs up if you think it is a solution. A lot of slamming fists on desks. We think it's a solution. A couple of people do not. Part B is a solution. Does anyone have any questions on either of these? It's interesting to watch students with the thumbs up system when nobody puts their thumb up and you go to put your thumb up and then you take it away. You shouldn't do that, because how do you know you're not the one person who got it right? Maybe you're the one brilliant person who caught something unusual about the question I put up. See, that has to do with social behavior. That's being a member of a group and being influenced by the group, whether you're right or wrong. You got to learn to stick to your guns, whether you're right or wrong. Okay? It also has to do with honesty. All right. We are doing well. We got a little bit more to go. Example 3. Looks pretty similar to the first example. But there's a couple of major differences that we're going to talk about, and this is where we up the complexity a little bit. So we're going to graph the equation y equals 1/2 x minus 1. But now we're given a domain, whereas before we were not. And the domain is written in this unusual format that we're going to try to understand. And then we are also asked to identify the range after we're done. That is also a challenge. But let's not worry about that yet. Let's just follow the steps. So could someone tell us or refresh us what's step 1? Step 1. Only 1, 2, 3, 4, 5, 6, 7, 8. Only half my class can tell me step 1. Maria?
Put it in function form.
Good. Put it in function form. So the original equation is y equals 1/2 x minus 1. So someone give me the first step in getting it in function form. Kayla? That was an outstanding statement that she just made. It is already in function form. Boom, step 1 is done. Step 2. What's step 2? Anissa? Put it in a table. So we're going to make a table of values. Excuse me, I'm sorry. So what numbers or what values should we choose for our x's? Because we have to pick some intelligent ones. We've got a lot of people who feel confident. Brian, and then we'll go to Zabari.
Wait, do I give you all?
Just give me one.
-6.
-6. Zabari, what were you going to say?
-3.
-3. Okay, so we have a bit of disagreement on the first thing that I should put down. So let's make an argument. Why -6?
Because since the x can't be greater than 0, then we can't use positive. So
Okay, where did he get that from? Because I don't remember hearing that. I didn't say that. Where did he get that statement from? We got a bunch of people. Maria?
It says right there the domain of x is less than or equal to 0.
That's right. So that was excellent. And Brian's interpretation, again, is right on. X cannot be greater than 0. So you cannot use any positive numbers. So that's why he chose a negative number. That was brilliant. But why a -6? Why not -5 or -30?
So you can make it nice, because if you use an odd number, you're going to end up with a decimal.
Okay. So we want to try and use, you said if we choose an odd, we'll end up decimal. So which ones should we use?
Even.
Evens. So we want even negative numbers. So that's the kind of thought process that you have to go through. So Zabari, you said -3. Do you want to change your thought?
-4.
-4. Okay. So let's start with smallest to biggest. We put in a -6, -4. What would the next logical choice be? Alicia? -2. And then what would be the final choice? Brandon? 0. If you can get a 0 in there, I would highly recommend trying to always get a 0 in there because it makes your life really easy. Now we're going to plug and chug it out. So we got 1/2 times -6 minus 1. Got to be careful. What does that come out to? Catalina?
-4.
Comes out to -4. What about when we have -4 as the input? 1/2 times -4 minus 1. And I know I'm supposed to be putting parentheses around this, but I'm writing this middle part quickly, so I'm taking some shortcuts, and you can do that too, as long as you understand that this is really multiply and multiply. So what do we get when we do this one? We got a lot of people. Sebastian? -3. Anyone want to make a prediction as to what's going to come next? Ania? -2 is going to come next. Because I followed a pattern here, the pattern's going to continue here. What will the next number be? Alyssa? -1. So I, using my intelligence and understanding of patterns, can actually skip a bunch of work to get the results. Now we're going to plot the points. So we have ordered pairs, -6, -4. -4, -3, -2, -2, 0, -1. Okay? So, draw a coordinate grid. -6, -4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. -4, 3. I'm sorry, -4, -3. 1, 2, 3, 4. 1, 2, 3. -2, -2. And then 0, -1. Does anyone have any questions about how we did that? Now, if you already drew your line, you might have to erase something because this line is going to look a little bit different. If I take these points and I draw a line through them like this, that's what I taught you to do a little while ago. What's the problem? Sharif?
They give you specific domains, and it's not possible to actually predict like what's going to happen like at the others.
Yeah, this whole part of my line is wrong because the domain, and I love the way he said it, gives a specific domain. The domain says that x cannot be greater than 0, which means that my line actually will not go this way. It will only go that way. So, you have to be careful. Is that easy? No, of course not. You have to pay attention to details. So your line's going to go this way, and there's only going to be one arrow because it's not going on forever this direction. Brandon.
So when it's less than or equal to 0, more than equal to 0, more like a rate.
It's more like a rate. Oh, it's array. I'm sorry. I thought you said rate. Yes, it is array. Exactly. And that's a very advanced word that you're going to learn more about next year in geometry. Yeah, this is array. Array has a point on one end and an arrow on the other. Very good. Tristan. You mean just draw this quadrant? If you knew ahead of time, yeah, you could have done that. I didn't know. I'm not that advanced. I wouldn't have known. But if you can recognize. So the last piece is we're asked to identify the range. And when you're given a domain in this format, we're going to give the range in that format. So what we have to do is be we actually have to interpret what we have found. We have to look at this output. This is not the range. You're used to writing a list of numbers, but it's not a list of numbers because we chose these. We could have chosen a whole bunch of other ones, right? We could have done -8, -10, -12. We could have gone on and on and on. So you can't just say that the range is -4, -3, -2, -1. We're going to write it like this. We're going to write y, and then we're going to use an inequality symbol. Look at these numbers. What inequality do you think we should use, and then what number should be on the other side? Got some people who are catching on. Go ahead, Jada.
Y is less than or equal to.
That's exactly right. Y is less than or equal to -1 because this is the smallest possible domain value. That means this is the smallest possible range value. So what you have to do is, when you're given a domain like this, you want to use the smallest possible value so you can find the smallest possible range value. And then all the other numbers are smaller. So it has to be less than or equal to. Okay? You guys are doing a great job. I'm going to pause here. We have one last idea to go over. And I hid part of this on purpose. What does the graph of an equation like y equals -3 look like? So I'm going to do something up here. I don't want you to copy it. I just want you to, so you can put your pencil down, I want you to look, watch, participate, try to understand. So if I were to make a table of values for this, I'd have my x, my y. My function is a little hard to put in, so I'll write y equals -3. So could someone give us some values that we could use as our input values? Okay, guy?
-1, 0, 1, 2.
Okay, so that's probably the best choice. So let's plug it in. Anyone have any issues or concerns about plugging in the -1 into that equation? Brandon? Yeah, how do you do that? Alyssa?
I don't understand how that works.
Yeah, well, it's confusing. Why is it confusing? Why is it confusing? Tristan? Yeah, why is it confusing?
It's confusing to me because there's no x in it.
Exactly. There's no x in the equation to plug the value into. So what that means is, no matter what value you use, y will always be -3. X is 0, y is -3. X is 1, y is -3. X is 2, y is -3. What that means is, no matter what, y will always be -3. So what does this look like when we graph it? So, let me bring up the graph. If I do -1, -3, -1, -3 is right there. 0, -3. You should start noticing something. 1, -3. 2, -3. So what do you notice already? What do you notice, Sharif?
It's a horizontal line.
Yeah, that was beautifully said. It's a horizontal line. When I draw the line through the points, this is what you end up with. This is the graph of the equation y equals -3. So, what does this mean? This means that when you have this situation, there's no work involved. You just have to understand what it looks like. The equation y equals -3, what I would do is put a point at -3 on the y-axis, and then draw a line horizontally through it. Any questions so far? So, if y equals -3 is a horizontal line, what do you think x equals 2 will look like? What do you think that will look like? We got a lot of people who think they have an idea. Ania? It's going to be a vertical line. Where do you think the vertical line will be? Where do you think it will be? Kamoy? Between 1 and 4. Oh, I like the way you said that. Could someone say it a different way? Brian?
A horizontal line in which the x are on the point that it reaches the x-axis will always be 2.
Okay, so you disagree with what Ania said, because she said a vertical line. You think it's going to be a horizontal line.
No, I meant to say vertical.
Oh, you meant vertical. Okay. So, yeah. So, the x value is always going to be 2, which means the vertical line is going to pass through the 2 on the x-axis, and we are going to draw a vertical line through it. So, y equals is going to be a horizontal line, and x equals is going to be a vertical line. This is actually confusing because you would think it's the opposite. When you think of x, what are you usually thinking of? Right? So this is a concept that's counterintuitive. Now I want you to fast forward in your mind. A week from now, you're going to get a quiz. I'm going to give you something just like this. What do you think some of my students are some of my students are going to do accidentally? Catalina?
When they see x, they're gonna do a horizontal line.
Yeah. I think a lot of my students, when they see x equals 2, are going to draw a horizontal line like that. But that's a mistake. And so right now, you have to get it through your head somehow that it really means a line passing through 2 on the x-axis. It's passing through the 2 on the x-axis. So it has to be a vertical line. So is that easy? No. But think about this. On a quiz or a test, should you be spending any time on these questions? No. So these are actually gift questions. Everyone should get these right instantly. But you can't mess it up. You can't accidentally do it the wrong way. Kezekiah.
How do you do it are you gonna ask for the y?
No, I did this as a demonstration. I told you not to write this down because it's not necessary. I'm trying to illustrate to you why it becomes this. You can't generate y values from this. It just doesn't make any sense. Okay? Any other questions? Good. Draw a line across your paper. Your classwork is page 33. You're going to do 16, 15, 14, 9, 6, and 3. Let's see how we're doing. Here's number 16 and number 15. Number 16, you were asked to graph and identify the range. So that took a little bit more thought, a little more effort. Unfortunately, if you have the same graph but you drew the line all the way through, that is actually incorrect. That's something we talked about. And the range, y is greater than or equal to -2. If you got part of it right and part of it wrong, you can give yourself half. That's not a big deal. Number 15, this is what your graph should have looked like. Number 14 should have taken you a nanosecond unless you got confused. And then numbers 9, 6, and 3. Number 9, you were asked to put it in function form. Number 6, same thing. Number 3, you were asked to identify which of those 2 points was a solution to that equation. I will open up the floor for questions on anything at all. Questions? Anil, we'll start with you. Number 15. Okay, so let's take a look at number 15. Give me a thumbs up if you got the correct graph for number 15. Okay, so we got a lot of people who are confused. Maybe it's because of this 0 sitting here. I'm not sure. So let's go step by step. Step 1, you're asked to put it in function form. Step 1. Function form. There's my thumbs up students again. Sharik, what does this come out to in function form?
-2y equals -36.
I'm very confused. That's not function form.
Yeah, I mean y.
Okay, so what was the first step you did? You did what?
I did -2y equals -36.
No, but what is your first step? What did you do to get?
I subtracted 3x from both sides.
So you subtract 3x from both sides and you get -2y equals -3x. Now you can put plus 0, but we don't need to because there's no value there. So now how do I get it in function form? Zavari?
I subtracted. Oh, you didn't do what you did, but you didn't do it.
Okay, what did you do?
Well, I took the equation and I just subtracted the. Oh, I see.
That is
And
what
you
we
just
did.
divide -2.
Yeah, divide both sides by -2. I'm not sure why. This is easier than most of the ones we've done so far, so I'm not sure where we're getting tripped up. Again, maybe the 0 is throwing you off or something. But we end up with y equals 3/2 x. So, that's all.
The 0 makes it like
So now, step 2, make a table of values. And you don't have to write step 1 and step 2 anymore. I'm doing that so my students who are struggling a little bit can be clear. But we need a table of values. So we have our x, our function in the middle, and our y. Now it is a little bit tricky to figure out what values to use, but it's really not that tricky. Again, it's all based on the denominator. So could someone give me a suggestion for a set of values? Brandon? -2 would be a good suggestion. And then where'd you go from there, Brandon? Yeah, that's a perfect set of values. All you have to do is look at the denominator. That will tell you what you should be, what your sequence should be. So now plug in 3/2 times -2. What does that come out to? Is that the sticking point? Is that the part that we're not getting? Ania? Yeah, it's -3. 0 is going to be 0. 3/2 times 2. What's that going to be? Kayla? 3. And you should see a pattern emerge now. So what's the last output value going to be, Kamoy? 6. So now plot the points. -2, -3 is right here. 0, 0 is right here. 2, 3 is right here. And then I didn't fit it on the graph, but 4, 6 will be right about there. So again, I'm not saying this is simple in any way. But if the issue is you didn't know how to multiply a number times 3/2, then that's something that I can't help you with. That's something you're already supposed to know. Catalina and then Ania.
Is it okay to skip number 2?
What do you mean skip number 2?
Step 2.
How'd you skip it?
Because I just look at the slope and then I start.
So you already know slope-intercept form, so you took the shortcut. That's fine. I have no problem with that, except you have to know how to do this. So you will be asked to make a table of values and give me the table. As long as you can do it, I don't care how you do it. Okay? As long as you know how to do this, I don't care how you produce the graph. Ania?
I thought it was a different result because you didn't plot the value.
I'm confused by your statement. Just say it one more time. You
I
thought what?
It was a different formula or different steps to do if you didn't plot the value.
Okay. Well, does this clear up the confusion for you? Okay. Kezekiah? Number 3. Okay. Are there any follow-up questions on number 15? Okay, let's take a look at number 3. What's the question? Okay, well, what does the question actually ask? Could someone read the instructions for us? And?
Decide which of the 2 points lies on the graph of the line.
Okay. Decide which of the 2 points lies on the graph of the line. Okay. Well, it doesn't ask you yes or no. It asks you to decide which point lies. So I'm asking you which of these, A or B, is a solution. I already know where the confusion is. What letter is right there? Okay. So. Oh, so you just misunderstood the instructions, and so you wrote no or yes?
Yes.
Oh, okay. Well, did you get yes for part
Yes.
All right, so then you got it correct. But you got to read instructions, okay? Other comments or questions? Good. Draw a line across your paper. Your homework is page 223, numbers 4 through 30 even, and 36 and 38. That's a total of 16 questions. You're going to read the next section, and you will have a quiz next Wednesday. And that will be 4.1 to 4.3.